Hot coffee becomes cold on its own, while it cannot become hot again on its own. The air leaks from the balloon on its own after some time. Water always falls downward on its own, but it never goes upward automatically. A stone or any object always falls down on the ground on its own. These objects never goes up automatically.
But the most important question, why do we use the second law of thermodynamics?
You have seen from the examples that all processes takes place on its own, and they also occur in a particular direction.
If we keep the hot cup of coffee in the room, then it will cool down after a few minutes. That means heat transfers from higher temperature body to lower temperature body, and this process occurs on its own. But what about the reverse process? Will the reverse process occur on its own? Will the heat of the room be transferred back to the cup of coffee? Well, the statement of the first law of thermodynamics states that this process is possible. You knew that, right? However, this is the only limitation of the first law of thermodynamics, that it does not describe the direction of the process. In order to overcome the limitation of the first law of thermodynamics, the second law of thermodynamics was discovered. The law is used to check whether the process is spontaneous or not. It also tells us the direction in which the process will proceed. The second law of thermodynamics can be classified in three ways. First, the Kelvin-Planck statement.
According to Kelvin-Planck's statement, it is impossible to conduct a device which works in a single heat source and converts all of its heat completely into work.
This Kelvin-Planck statement simply wants to say that a heat engine must exchange the heat with at least two thermal reservoirs, one at a higher temperature and other at lower temperature. Then only the engine will operate.
The figure shows that the engine is continuously taking heat from the heat source and converting this heat into equal amount of work.
Secondly is the Clausius statement.
According to Clausius' statement, it is impossible to conduct a device that can transfer heat from cold body without absorbing any work. In simple definition, heat can only flow from colder body to a hotter body.
Thus, such device cannot transfer heat from lower temperature body to higher temperature body without any supply of work to it. Lastly, the second law of thermodynamics based on entropy. There are two terms to remember: randomness and entropy.
Randomness. The movement of molecules is known as randomness.
Considering solid shows less movement of molecules, liquid have more movement of molecules, and gases show maximum movement of molecules.
Thus, we can say that solids have less randomness, liquids have more randomness compared to gases have maximum randomness.
Next is entropy, the measurement of disorder of the system.
In solid, the molecules are properly arranged. That means it has less randomness, so entropy of solid is least. In liquid, the molecules move very fast throughout the container. It has more randomness, which means it has more entropy. The entropy of gases lies in between solid and liquid.